Hello and welcome to the Programming in C++ series. We're going to do Chapter 3 Input and Output Exercises. Before we do, go ahead and smash the like button, leave a comment, and subscribe to the channel if you haven't done so. So let's dive into our first video, which is Programming in C++, Programming Exercise 3-10. And with Exercise 3-10, Paula and Danny want to plant evergreen trees along the back side of their yard. They do not want to have an excessive number of trees. Write a program that prompts the user to input the following: the length of the yard, the radius of a fully grown tree. Use 3.14159 as a constant value for any calculation that may need pi or dollar. The required space between fully grown trees. The program outputs the number of trees that can be planted along the back side of the yard. The total space that will be occupied by the fully grown trees. Format your output with the set precision to ensure the proper number of decimals for testing. And test 1 just needs a number and spacing for trees correctly output. So we'll shoot for that. Let's look at our code. Make it a little bit bigger. And right, first thing we need to do, we need to input our IO include statement, which is IO meta. Then after namespace, we have a one name constant, and that is our double. Once again, constant double is pi, and it equals 3.14159. There's semicolon. Let's go down and do some cosmetics. Let's get this moved out of the way so we can have some room to work, and let's slide our bar down so we can to work. Alright, first let's declare our variables. They're all doubles. There's 3 of them. First one is yard length. My favorite word to spell. Then we have tree radius. Then we have distance between trees. Right, double between trees. And okay, got it. Semicolon there. All right. Now let's do our, we have one more, we have an integer, forgot about that. Let's stick a space right here. Integer, and we'll call this number of trees. Since there's no decimal in that. Number of trees. So let's see out, do our precision, or set our precision. Fixed, show point, set precision 2, and semicolon. Alright, next, see out. Let's go with enter the length of the yard. Enter the of the yard. The yard. And semicolon. And we're going to go cn. And that'll be yard length. Yard length, colon, T, and line. Alright, so we'll use this 2 more times. So we have to do Next, we're going to enter the radius of the fully grown tree. Tree radius. Down here. So one more time, and this time we're going to do distance between trees. So, distance between fully grown trees. This is going to be distance between trees. Alright, we got that licked. Let's go down here. There, we'll do some math. The number of trees equals static underscores cast integer and space is going to be yard length. Is 2 times tree radius and plus distance between trees. And both of these close in parentheses, so we have a semicolon that. And now let's see out. Total area occupied by trees. Trees that can be planted. Planet here. There, and then let's go number of trees. And line. Right. So looks like we got everything. Now we got one more. See out. Total number of, let's go total area occupied by the trees. Now let's do this right here. Area occupied by the trees here. Total of trees that can be planted. Total area occupied by trees. And let's see. Number of trees. No. Let's go. Let's get this here. Let's go pi times tree radius times number of trees. And let's do that. so let's go back up real quick. We got our include statement, IOManip, our constant double, our 4 variables, 3 doubles and 1 integer, number of trees, our set precision, enter the length of the yard, enter the radius of the fully grown tree. Radius, enter the distance between fully grown trees. And total of trees can be planted. Total of trees. Total of trees. Total number of trees. 6. Total number of trees that can be planted. Alright, so let's go ahead and run this. Run it. And while we're running that, we'll look at a code. Give you a glance at it. Give us time. Yard, let's say 1, that's too big. Let's go 85. To the radius of fully grown trees, 42. Enter the radius between fully grown trees, 17. Number of trees that can be planted. Let's run it again. Let's go 1, 2, 10, 8. 17. Total area occupied 150. 8 trees. So let's see total area that can be occupied. Why do I have that? Trees. Okay. Planted. That's why. This. All right, let's run it again. So make sure you do that on line 35 with your space. Your space after your colon. Run it again. 5, 6, 14. There we go. Now get the right output. So let's go ahead and calculate that. And we're going to look at the code while it's being calculated. So if your work, check out line 2 to 21. If you got some changes to make, go ahead and pause that. Scroll down to the end. I'm going to scroll all the way over for line 31. There we go. And we got some work to do. Let me pause this. Actually, we'll fix it right after this. Alright, I found one error by the trees on this line. And I'll try to run it again and I'll come right back. Alright, so we did get 100%. Let's look at the code. I got it small so we can see it all the way across. Alright, so here we go from 2 to 21. Go ahead and pause it if you need more time. And there's 24, there's the rest of it. And on line 32, if you need to see that, this is between trees, 2 closeout parentheses with a semicolon. Alright, so go ahead and pause that if you want to see that again. Alright, so let's go on to the next one. Programming C++ Programming Exercise 3-11. And we've got a size of a jumbo candy bar with rectangular shapes is LXWX, or L length times width times height. Due to rising cost of cocoa, the volume of the candy bar is to be reduced by P%. To accomplish this, the management decided to keep the height of the candy bar the same and reduce the length and width of the same by the same amount. For example, if length equals 12, width equals 7, height equals 3, and P equals 10, then the new dimensions of the candy bar would be 11.39 times 6.64 times 3. If Below is an example of how the completed program should work. Enter the length, width, and height of the candy bar separated by space, 12.7. Enter the amount of the reduced volume as a percentage, 10. The new dimension of the candy bar is 1130.38 times by 6.64 by 3.00. Format your output with the set precision to ensure the proper number of decimals for testing. Correct dimension output of the new candy bar size. Alright, so let's go ahead and do this. We'll start by adding our IO streams. Let's go include, or our include statements. IO streams. Alright, so let's go IO manip. Then another one we're going to use this time, we're going to do math.h. Right, and we have no constants to claim, no name constants. So let's do our cosmetics, create some room to work, and we have some variables, and they're all going to be doubles. So let's do double length. Let's go width, thickness, and P, Q, and B. Alright, so let's do our set precision. Oops. 2. Now let's go see out, and we'll say enter the length, width, and thickness of the candies separated by spaces. The width. So first enter the length, width. Thickness of the candy separated by spaces. Let's do this. With thickness. And inline. Time, see out again, we'll type it up. Enter the amount, the reduced volume as a percentage. Enter the amount of the reduced volume. So enter the amount of the reduced volume as a percentage. Go in and see again. Cancel out. Inline. So let's go do let's do Q equals 1 minus P divided by 100. course, I've said that before, but hey, let's see what we got. All right, we got our arrow manip math.h at length with thickness P, Q, and B. Fixed show point set precision 2. Semicolon with that. Got our semicolon behind that. Enter the length, width, and thickness of the candy bar or candy separated by spaces. And then enter the amount of the reduced volume as a percentage. And everything else looks good. One more thing. I almost forgot this. We're just going to cancel out or see out the new dimensions. Of the candy are. So there'll be the new dimensions, and let's go ahead and here. Let's go B times length and then X space both sides. Times width another X both sides, space R on both sides, let's go right there, and thickness and end line. So, alright, so let's bring this up. So we got no chromatic, no spelled words. Spelling is terrible. Alright, enter, reduce. Alright, we're going to run it and then we'll check the code after that. Go and draw that, we get to check it again anyway. So I'll show it to you while it's calculating. Oh, it's already calculating, it's not calculating, it's running. Calculate, it's going to get 0. Alright, so enter the length, width, and thickness of the candy separated by spaces. Let's go 8, oops, 18, 3. Percentage, 7. Candy are 0 by 0 times 7. That was 3, what? Yeah, that's definitely wrong. Alright, let's calculate that, see what we did wrong. Alright, so that's calculating that wasn't correct. So let's see what we did wrong. Let's show this away. Alright. Correct dimensions output, test 1, failed, test 2. Enter the length, width, and thickness of the candy separated by spaces. So we have, I hope they don't do just for that. Let's try and right, so over one space, let's run it again. Let's go 15, 9, 2. So let's just go 3. 0, 0, 2. That's definitely not right. Alright, so let's calculate it and let's look at our code, see what we can find that was not, something's got to be out of place. With thickness PB, it's got to be our math down here. So times 100, space there, 3 times length, X b times width, square root of cube. Maybe it was that space. It's got to be that space because it wouldn't divide by 100. Let's run it again. And let's go 18, 4, 18, 7, 3. Percentage, 4%. Still looks shabby. We'll try one more time. Calculate that. And run. I don't know what else. Okay. So let's and still we're still getting that 0. So let me pause it and do it again. So I redid it, and I'm going to put in my input 18, 6, and 3. Percentage, so 3%. Now we got real numbers here, so I guess that is direct. Got it correct. Couldn't find any mistakes, so I retyped it. This usually happens when I'm not talking. Alright, so let's, hopefully we got that 100%, but we'll show you the code while that's finishing up. So you have same these two, you have your variables, fixed, show point, set precision. So if you're looking at line 20, yep, looks like something happened there. So it did get 100%, so this code is correct. We can close that, and there's 100%. So I'll show you the code, and then we'll get on to the next one. Alright, so if you're looking at line 1 through 20, you can check that out. Now go ahead and pause it. So we're going to slide down to the next. Now here we go with the rest of it. So if you need more time with the code, sorry about that. If you need more time with the code, go ahead and pause it, and we'll see you on the next one right after this.